Hey everybody, Miguel here. In today's video, I want to continue from a previous video where I show you how to create an Apigee Java Callout. This is the Java Callout I'm referring to. Check out the links in the description if you haven't looked at the previous video. So what I want to do today is that we're going to take this Java Callout and we're going to take it to the next level. Let's do some actual useful stuff in the Java Callout. I'm going to use an external library to make a call to a message queue, and we're going to push a message into the message queue. We're also going to integrate the Java Callout better with the Apigee proxy so that information such as username, password, and the endpoint can be parameterized outside of the proxy instead of being hard-coded. All right, so let's get started. So the first thing we need an actual server-side message queue to push messages into. I don't have anything deployed right now, so I'm going to do that quickly in the Google Cloud platform. I'm going to be using a very popular software called RabbitMQ to do this. So let's switch over to the UI for the Google Cloud platform. So over here, let's search in the marketplace. There is already an offering for RabbitMQ that I have used before, and I know that it works just fine. Now, this is not going to be meant for production purpose, so you don't actually need a big deployment, so the default settings here are fine. And while this is deploying, I'm going to speed up the video so you don't have to wait. So looks like the deployment itself was successful, and it gave us some basic information about the installation. So the first thing we need to do is we need to enable the RabbitMQ management UI, and for that I'm going to SSH into the machine. And there's a command that I need to run to enable it. I don't remember it by heart, so I'm just gonna search it. There we go. This is it. And yeah, here's the command. So now let's run it. And that's it. The management UI has been enabled, but in order to access it externally, we need to open up this port in the firewall rules. So that's what we're going to do next. Okay, let's look at firewall. So let's create a new firewall rule. I'm just going to call this RabbitMQ. And the port number is here. Now we need to specify the source and target. So for target, actually let's do the source first. So for source, I'm going to allow any IP address to access it. And for target, it will be just the VM that has RabbitMQ. And to do that, we can use the network tag for this VM. And let's put it down here. And I think this is it. Let's create the rule. Great. So we can actually go ahead and test this now. So let's grab the external IP address. And in a new tab, we'll go here. And oops. Great, so it looks like it's working. Let's try logging in. Okay, here's the username. And let's grab that password as well. Cool, so we're in. Let's go into queues, and I'm going to create a test queue that we can use for a test. Okay, is it a durable queue? Yes. All right, let's create the queue, and it's there, it's empty, there's no messages right now, and we're going to change that by pushing a message from the Java Callout extension. Let's go back to the code. All right, so one of the, or at least the first thing I like to do whenever I'm creating a Java callout is that I like to write the code first and run it locally before it even runs in Apigee. That way I can be certain that it works and there's no issues with it, and then I can run it in Apigee. So I can rule out any issues that happen and know that the code actually works. So if there's a problem, it's not because there's something wrong with the code, it's something else I have to troubleshoot. So to start, let's look at an example of how do we push a message into RabbitMQ. All right, so let's head back to RabbitMQ and look for examples of how to connect to RabbitMQ. Okay, so I'm just going to search on Google for RabbitMQ Java example. And let's go here. I've been here before. And let's make sure we pick Java in here. Okay. The Java client library. So the Java client library for RabbitMQ looks like it's also available on Maven. So we can just declare a Maven dependency and we will get the jar file that has the client library. Let's search for this. Okay. And let's use the latest version. All right, and let's bring this back into Maven. Let's put it down here. And you can see IntelliJ is updating. That means it actually detected the change in the POM file, so it's downloading the new jar file. And it's actually in here. And it looks like it also comes with SLF4J, which is a login library. We probably don't want to bring this into Apigee. I'll show you later on how to make sure that only the library that you need goes into the callout and nothing else. Anyway, so let's go back to the doc. Now let's look for an example of how to connect and send a message. So it looks like this is it down here. And first we have to import the classes that we're going to be using. So let's do that. Okay, next. Looks like they're declaring a variable it's holding the name of the queue. They're using hello as the name. For us, this is going to be test queue. And then they're creating a factory and creating a connection and its channel. So let's copy this. Okay. So obviously this the URL for our instance of RabbitMQ is not local. It's going to be that one, the one that we just deployed, so this needs to change. Also, we need to pass a username and password because it's protected. And here we can see that both the connection and the channel are created within this try with resource, which means that as soon as the block is done, it's going to close the connection and the channel, so we don't have to worry about that. This is something you have to think about when you're creating a Java callout. You want to make sure you're not leaking resources, and connections is one of those things. You don't want to leave connections open. So before we keep going, let's take a little bit of time and clean this code a little bit. First thing, we're going to parameterize all the stuff that, all the arguments that are needed to send the message to the message queue. So right away we can see we have the host name. So let's create a variable for that. In addition to the host name, we're going to need the port number. We're also going to need the username and the password. There might be other stuff later, but I think this is it for now. So let's set the host name and let's set the port, and look like it's an integer. So we need to convert this from a string to an integer. Okay, next let's set the username and finally the password. Great. So we have all these variables set, but we haven't actually sent the message to the queue. So let's go back to the tutorial to see how that is done. And okay, yeah, it's down here. So here's the message, and this is how you send the message to the queue. So let's put that over here. And let's move out the message. And we also need a queue name. Let's declare a new variable for this. And this is test queue. And I think this is it. So the next thing we can do is we can move this into a separate function. Or separate method. The reason why I want to do this is because I want to test this locally on my laptop before I test it on Apigee. And if I move it into another method, then I can call the method from a main method. So let's do that. So we can tell IntelliJ to do refactoring, and we can tell it to extract this as a new method. Let's make it static, and we'll name it send message. So this is what it will look like, and it detected that, hey, there's some exceptions thrown out, so it's doing all of this for us. Let's do the refactoring. Great. So we have host, port, username, password. Where did the message go? Let's undo this. Oh, okay, I see the problem. So queue name and message was part of what I had highlighted, so let's move this out. And let's try to refactor it again. Refactor, extract, method. There we go. Yeah, it looks correct now. Great. So this is better. And yeah, I think this is it. So let's write a main method and try this out. I'm going to just copy paste all of this down here and call the method. And looks like IntelliJ, the compiler is complaining that, hey, this method is throwing some exceptions. Are you going to handle them? I'm not. At least not now. I'm just going to let them bowl out. For the actual callout code, we do have to do something with the exceptions that are thrown out. And usually what you do there is that you catch them, and then you create a new flow variable in Apigee that contains the error message and the name of the exception. That's usually enough to help you troubleshoot. Okay, so let's fix this. Great, so the exceptions are now in the signature, and we actually have to put the proper hostname, port, and username and password. So the hostname is the external IP address for the virtual machine. So let's grab that. Let's put it over here. The port number, that it's actually I don't remember by heart, but let's just Google that up. Oh, there we go. Okay. Now this port number, this is the RabbitMQ's non-TLS port number. For TLS connections, they have a different port, and we can look at that later, but for now, since this is just the beginning, we're testing this, we're going to be using non-TLS. And username, we can grab this from over here. It says just user. And let's copy the password. Great. So I think we have almost everything. We can try this out. So IntelliJ actually makes things super simple. I don't have to compile it and run it myself. I can just click over here and it will do it for me. And let's see what happens. It looks like there are some warnings in here about the logger. I'll just ignore that for now. And it's taking quite long. Let's see. Oh, there we go. There was an error. So looks like there was a connection exception timeout. Okay, I think I know what happened. So earlier we opened the port for the UI, but we didn't actually open this port. So let's edit the firewall rule that we created earlier to include this port number as well. Okay. Edit, and I'm just gonna add it over here and save. Hopefully once this is open, then we should be able to just rerun this, and let's see what happens. Okay, yeah, successful. Exit code 0, that means no errors. So we can actually go into RabbitMQ now and see if the message was received or not. Okay, right here. So yeah, we have one message ready to be read. So let's see if we can pull it. Okay, yeah, so we can do a get message. And there we go. That's the message that we just sent. So for the next step, let's actually get this ready into a jar file that we can put in Apigee and try it out from over there. All right, so how exactly do we package all of this into a jar file? So remember, we're not just packaging our code, we're also packaging the library, this one right here. Right, so there's a way to do that, and first I'm gonna show you what happens out of the box with Maven if you just do the Maven package command. Okay, let's do that. So back in here in the terminal, let's clear this and Maven package. So it is successful, but if we inspect the jar file, let's see what's inside. You can see it only contains our class file, nothing else. So this is not going to work. Apigee needs to have the other class files for the client library. So next I'm going to show you how to do that. And it's actually not that difficult. There's a Maven plugin called the Maven Shade plugin that basically takes this jar file and it looks at the dependencies in your code, and it also packages those dependencies into the same jar file. So let's do that. Let's head over to Google and search for examples of how to use the Maven Shade plugin. Okay, and right here we have examples. Let's just copy this example. Now let's go into the POM file and paste this. So it's already configured, but this part right here, this is not applicable to us, so I'm just going to comment it out. For now, I'm not going to exclude anything. Let's just see what the jar file looks like when it gets created. So let's rerun the Maven package command. And we can see here that when the Shade plugin runs, it actually creates a new jar from the old one. And yeah, so we have the original jar and then the new jar created. So let's see what's inside the new one. And yeah, it's different. So right away you can see we have the SLF4J library. There's a lot of class files in here from that library. We shouldn't have this in here. I mean, this is not needed for our use case. We're only interested in the main client code, which is this stuff right here, com RabbitMQ client. Let's see what else is in here. Yeah, look like that's pretty much it. So the client, oh, we also have the these other two jar files in here from Apigee. We don't want to include these jar files or these classes within the jar because this is already included in the Apigee runtime, so there's no need to include it in our jar file again. Yep, so we have to do two things. We have to, or a few things. We have to exclude the two jar files for expressions and message flow, and we also need to exclude the SLF4J library. So if we look at the log from the Shade plugin, it actually tells us what's being included. So I'm just going to copy it from here. So this one we're going to exclude. Okay, we're also going to exclude the message flow. And finally, we're going to exclude the SLF4J library. Okay. I'm just going to follow the example here where they are putting the colon at the end. And let's remove this. So let's go ahead and rerun this. Great. So it was successful, and let's look at the output. So we can see right away that it's excluding those libraries that we told it, hey, don't put it in the jar. I only put the client code. And we can actually inspect the jar again. And yeah, you can see that it's only the RabbitMQ client class files. There shouldn't be anything else other than our own class file, which contains the custom logic that we have for sending a message. Let's see. Yep, that's it. So we have our own class file right here, plus the RabbitMQ client class files. So I think we can take this now into Apigee and try it out. Let's go over there. Alright, so we're going to API proxies, and I'm going to reuse the same proxy from the previous video, and I'm just going to edit that and re-upload the jar file to replace the old one. Alright, so let's go into my home directory. And in here, let's choose the jar file again, open it, and update. Let's save the proxy. And let's go and actually test it. So in the trace tool, let's start a new session and let's send a call. And looks like there was an error. What was this error? Execution failure. So I can't really tell what was wrong. Remember how I said earlier that it's a good practice to catch the exception and put the message in there. So maybe right now it's a good time to do it. So let's go back over here. Actually, I think I know what is wrong. I didn't fill out anything here. So yeah, it's gonna fail. But just for the sake of argument, let's do the proper thing, which is to catch the exception, which we're already doing, and then let's create a new flow variable that contains the error message. And the name of the flow variable is really up to you. It could be anything. I'm just here picking the same name as the callout and just putting .error in there just so that it's clear when it shows up in the trace tool. And now for the error message, I'm going to get the exceptions class name and concatenate that with the actual text of the message. And let's recompile this or repackage it and upload it again and try it. Alright, so it's recompiled and repackaged. Now let's go back into Apigee, back into the trace tool, and upload the jar file again. Update, save, and let's test it again. Start trace session, send the request, and yeah, we got a 500. We knew this was going to happen, but we should see an error message. And there we go. Oh, so here, Apigee error, you can see right here, number format exception for input string. It doesn't tell us the line number, but I mean, this is a good enough hint to see what's going on. You can get creative here and maybe put the whole stack trace. It's up to you, whatever helps you to troubleshoot. So let's go back and fix the parameters. So we know this one's right here work because we tested them locally. So I'm just gonna go ahead and copy and paste this in here. Save this. Again, recompile, repackage. And let's head back into Apigee, upload a new jar file, and save. Then we're gonna test it again. Now this is an iterative process, right? So you're developing the Java callout, you make fixes, you test it again. I'm using the Apigee UI to do this. You don't have to. There's other ways that you can automate this process, where also using Maven you can push changes to Apigee and have a test case that runs and tries it out. For now I'm just using the UI because it's quick and easy. I can show you in a different video how to do this same thing with automation. So let's go into trace, start a new trace, and send it. Great. So now we got a 200. This is good, right? So it worked on our laptop. It also worked in Apigee. And there's nothing interesting here because I didn't write anything for the successful case. But if we go into RabbitMQ, we should be able to see now that there is a new message. Yep. So you can see here, there's a new message ready. Let's consume this message to remove it from the queue. And yep, there it is. So this is great. So the code now is actually running in Apigee. For the next steps, what we're going to do, we're going to, all those parameters that we're passing hard-coded in the Java code, we're going to define them outside and pass them into the callout. Let me show you how to do it. So let's go back into the Apigee UI, and back in here in the Develop tab, we can edit the Java callout. So the way to do it is that you can declare a properties array, and within here we can pass a property for each of the parameters. So let's start with the host, and then we can pass for the other stuff such as the port number, the username, the password, the queue name, and the message itself. Let me populate these values so we can grab them from over here. Let's paste it in here. So the IP address for the host, the port number, the user, password, queue name, and finally the message. Now let's use a different message so that when we actually make the call, we can tell that it came from outside. Hello from Apigee properties, callout properties. Now let's save this. So next, let's make the changes in the Java code to actually read these properties. So back in here in the Java code, the way to read the properties is to create a new constructor. So when Apigee, when a new request arrives in Apigee, what it's actually doing is that it creates an instance of the class, of the callout class. And if you have a constructor declared that takes the properties, then Apigee will call that constructor. So let's declare that. And it passes the properties as a map of string to string. And we're going to store the properties as a private member of the class. So this should work. Let's just initialize this. And next, I'm going to replace this hard-coded values with the proper value from the properties. Let's put the port, the username, the password, the queue name, and finally the message itself. Great, so let's recompile and repackage this and we'll try it out. Let's go back into the Apigee UI, upload the new jar file, update, save, and let's test it out. Great, so it was also successful, which means that the message was sent, and we can go into RabbitMQ again and inspect it. So let's get the message. It says hello world. That doesn't sound right. Maybe I call it multiple times. Oh, there we go. Hello from Apigee. So I had done a few calls before this to test it out, so that's probably why there were a few messages in the queue. Let's actually do it again and make sure that the queue is empty and send a message. So the queue is empty right now. Let's make another call. And let's go back into the message queue. Get the message. And there we go. Hello from Apigee. So it is working. As you can see, the parameters are being passed from the configuration into the Java callout, and that's what's being used. So this is much better already, but it is still not ideal. Before we had these properties hard-coded in the Java code. Now they're still hard-coded, but outside of the Java code. They're hard-coded in the proxy, which is why I'm saying it's not ideal. Technically, all these values, we could define them outside of the proxy and bring them in as flow variables and read them in here. For example, if I wanted the message to come from a query parameter, I could go into the Java code and change this to, instead of reading a property, to use the message context itself. And from the message context, we can use get variable. And the get variable, we just pass it the name of the flow variable. So in this case, to get a query parameter, I would do request query param, and then the name of the actual query parameter. So we could use message, for example, and this would work fine, but it's still not perfect because we're accessing a flow variable directly from the Java code. So from somebody outside looking at the XML configuration, they wouldn't necessarily know that this is happening. It's an implicit coupling. So ideally, instead of doing that, what we could do is we could do something like this. Request query param message. And now it is very explicit. Somebody reading this code can tell right away that, yeah, the message is coming from a query parameter. Whereas before, unless they know what the Java code looks like, they wouldn't know what's actually happening. So how do we go about making this happen? Like Right now this wouldn't work, right? The way the Java callout is written, it's going to read whatever I have put in here. So the message is going to be exactly this string of text that I have in here. There's a way we can fix this, and to do that, we can write a small utility or a small helper that can interpret the properties when they have this special pattern with the curly braces and say, hey, looks like this is actually a reference to another flow variable, so let's go and look that up. So how do we go about making this actually work? So the way it is right now, it wouldn't work. The current Java code, all it's doing is just taking the string as it is and sending that as a message. Actually, let me just prove it to you. So I'm going to save this, and we're going to send a new request to send a new message to the queue, and then let's inspect that. So let's do it. All right, message has been sent. Now let's look inside the message queue. And you can see it's actually exactly what we typed in there. It didn't actually resolve the reference to the float variable, and that was expected. So in order to fix this, we need to go into the Java code and change it so that it understands that when it says this pattern with curly braces, that say, hey, let me replace this section of the message with the proper value, which would be whatever the value of the flow variable is at the moment. So let's do that. All right, so the idea here is that we're going to replace each of these method calls to read properties with a new method. And that new method is going to be responsible for, first of all, it will look up the value of the property, and then once it has the value of that property, it can look inside that value and see if there is any of those there are any of those special patterns with the curly braces, and if there are, it should replace each instance of that pattern with a proper value. So let's do one of them. Okay, so we're gonna call this resolve refs, and we're going to pass the same property name into it. Now let's create it. And so like I said, the first thing we need to do here is get the property value. Now, it is possible that we may not have the property at all, and if that's the case, property is going to be null. So if the property is null, then we can just return an empty string. Now, if the property is not null, that's when we have to do the additional processing where we look inside the property value to replace the special curly brace pattern. So one way to do this is to use a regular expression. Personally, I don't like to just go and start writing the regular expression directly here, because chances are I'm not gonna get it right the first time. Instead, I like to use an external tool that allows me to do more like trial and error until I get the regular expression working just right. Then I come back to the code. There are many of these tools out there, so I'm just gonna use one of the very popular one. It's called regexplanet, and let's go and choose Java. Now in here, that the way that this tool works is that you have the fields down here where you write the message that you're gonna test against, and up here you write the regular expression that you're crafting. So let's write a sample message. Let's say the content type is, and So I want to make this as realistic as possible. So this is an example of how you would get a header from a flow variable in Apigee. And the message is great. So these are two references. We have two references within this message to references to flow variables. Now the idea is that the regular expression would look through the message, find the instance of the references to the flow variable, and replace them with the correct value. Now the regular expression itself won't do the replacement, but at least it will locate the references, and then within the Java code we can do the replacement. So how would we match this? So obviously each of these references start and end with a curly brace, so right away we need to have that in the regular expression. But because curly braces are special characters in regular expressions, we need to escape them. So let's go and escape both of them. And we also need to match what's inside the curly braces. And as you can see here, there's different types of characters that are allowed in a flow variable. So you have regular alphabetic characters, A through Z, but you also have dots and dashes. So and also you could have numbers as well. So but even though I'm not showing it here. So in here, in the regular expression, let's say we're going to put a character class that's going to match A through Z, also 0 through 9, and also dot and dashes. I also have to escape the dash here because it has a special meaning inside a character class. Now, I have matched every possible character that can appear inside the reference, but it's only one character. I need to tell the regular expression that, hey, there could be one or more of these characters. So let's do a plus sign, and I think this should work. So let's give it a try. Great. So it looks like it actually worked the way we expected it. So you can see here, if you were to call the find method multiple times on the regular expression, the first execution will give you the first match, and then the second execution will give you this other match. So that's what we were looking for. However, it's still not the way that I want it. I want to extract just the name of the flow variable without the curly braces. So to do that, what I can do is I can put a parenthesis around the inside, and this creates what's called a capturing group. So let's run it again. Great. So you can see here that in addition to group 0, which is the whole match, we also have group 1, which is just the inside of the curly braces. So I think this expression is now in a good shape. We should be able to take the string and bring it back to the Java code and try it out. All right, so back here in the Java code, let's create a variable for the regular expression. And the first thing we have to do is we have to compile the regular expression into a pattern. And the pattern class has a static method that lets us do this. Great. So after we have the pattern compiled, then we have to create what's called a matcher. And the matcher will match against the property value. So let's do that. And then let me import the class. Great. So technically now we have executed the regular expression against the property value. The next thing is we have to keep calling the find method on the matcher and until there are no more matches. So to do that, we can just put a while loop. And once the matcher runs out of matches, this will return false. So it will not, it will stop the loop basically. Now, every time there is a positive match, we're going to have two groups. We're going to have group 0, which is the whole match, and we're also going to have group 1, which is just what's inside the curly braces. So let's go and grab the value of group 1. And I'm gonna call this the flow variable name. Now there's a chance that there may not be a group 1 match, so we have to check against that. And if there's no match, I think we can just move on. Or I mean, if there's no value for the flow variable name, we can just move on to the next match. Great. So down here now it means that we actually found a match and we have the name of the flow variable. So the next thing we need to do is we need to get the actual value for that flow variable. All right, so in order to get the value of the flow variable, we need access to the message context. And right now you can see here that resolve refs doesn't have the message context passed into it. So let's go and pass it in. Let's look at what the variable type is. Now we can use the message context to retrieve the value of the flow variable. Now it is also possible in here that the, there's actually a few things that can go wrong. One is that we don't have a flow variable at all, like that flow variable doesn't exist, so the result will be null. Or worst case is that the flow variable, the result is not a string. Although I think in this case, the get variable method returns a string. So I think what's going to happen is the runtime is going to cast whatever the flow variable is into a string. I guess that's fine. I mean, you should know what type of variables you're working with anyway. So let's check first if the flow variable value it's null, then there's no point in replacing anything, so we just move on to the next. All right, so down here we have guarantee that we found the flow variable with that name and we actually have a value for it. So what we can do now is we need to replace the original match in the string with the value of the flow variable. So to do that, we can use a string buffer. So I'm going to go ahead and create a string buffer. Then down here, when we actually do the replacement, we can tell the matcher to go ahead and append the replacement to the string buffer. Finally, when we exit the loop, there's still a section of the string that it wasn't replaced, but we still need to append it. That's the tail of the string. So let's do that. And then we can just return the value. Next, let's go back to the top and fix all those calls. And I think this should do it. So we can recompile and repackage it and try it in Apigee. All right, so we have the new jar file. Let's go into Apigee. Let's update the jar file. Update, save. All right, so next we can actually try it. So right now, everything's still being hard-coded except for the message, which is going to come from a query parameter called message. So let's go into the trace tool and give it a test. And great, it looks like it worked. And you can see the query parameter was received. So we should be able to go in RabbitMQ and check it out over there. Perfect. Now we have the message coming from a query parameter. Let's go back into Apigee. So how do we fix the other properties that are being hard-coded? Since we have this mechanism now working where we can pretty much retrieve the value of any flow variable, we can replace each of these with flow variables. So for example, the host and the port, they could come from a flow variable that's populated earlier, maybe by a KVM lookup. So let's give it some names for these flow variables, and then we can make changes to populate them. So let's say the host is going to come from a variable called RabbitMQ host. The port, similarly, RabbitMQ port. Now the username and password, since these are going to be sensitive values, I'm going to have them come from a key value map as well, but they're going to be encrypted, and encrypted KVMs can only, the value for encrypted KVMs can only be stored in private variables. So I'm going to name them private. And similarly, the password. Finally, the name of the queue, I'm just going to leave it hard-coded in here. Let's save this. So next, we're going to create two key value maps outside of the proxy. And in those key value maps, we're going to store the host and port, as well as a username and password. So to do that, we can go to the admin menu, and under the admin menu, we go to environments, and in here you can see key value maps. In the key value maps user interface, first make sure that you have selected the correct environment, then let's create the key value maps. I'm going to name the first key value map as RabbitMQ connection, And the second key value map, I'm going to name it as RabbitMQ credentials. This one is going to be encrypted, which means that Apigee is going to store the values encrypted at rest. Great. So now let's populate each of the key value maps with the entries for the necessary information. Let's start with the connection. So first we're going to do the host name, and this is the external IP. Next, let's do the port. Let me grab that. Now let's move on to the credentials. Let's put the username. This is just user. Now let's add the password. And that should be all that's needed. Next, we're going to go into the proxy and modify it to be able to retrieve these values that are stored in the key value maps. So in order to populate each of these flow variables with the values coming from the KVMs, we need to use an Apigee policy called key value map operation. So I'm going to be adding 2 of those policies, and then we're going to configure them. All right, so let's start with the first one to get the connection information. And let's do the second one to get the credentials. Now, these policies have to run before the Java Callout, so I'm just going to drag the Java Callout to the end. Now let's configure them. So the first thing you should do when configuring the KVM policy is that you have to specify the name of the KVM that you're going to be retrieving the information from. So, and we're not going to be using any of this stuff over here. We're only going to be retrieving information, so I'm deleting this. And we're going to be retrieving 2 entries from the KVM. First entry is going to be the host, and the second one is going to be the port. Now the host is going to be stored into a flow variable in the proxy, and that's going to be RabbitMQ host, and the port similarly is going to be RabbitMQ port. Let's save this. Now let's configure the second KVM policy. We can specify the map identifier, which is RabbitMQ credentials, and also we're going to be getting 2 elements. The first one is going to be the username, and the second one is the password. Now, this one's slightly different because the KVM, this one right here for the credential, is an encrypted KVM. We need to store, when we store the values in the proxy, they need to be stored into private flow variables. Now let's save this. So I think we're ready to test it. Let's go over to the trace tool. And let's start a new trace and send a request. Oh, so looks like there was an error. Let's take a look at the trace and see what's the error. And we can see right here the error is saying number format exception. And looks like the resolve ref method that we created earlier had some trouble and could not resolve this flow variable. I think I have an idea what's going on. So you see the flow variable here has an underscore, and the regular expression we didn't account that for in the regular expression. So let's fix the regular expression and recompile this. So the regular expression now needs to include underscore, and let's recompile and try it again. All right, let's get back here. Upload a new jar file. And let's try it again. Great, and looks like it was successful this time. Let's go ahead and take a look in RabbitMQ to see if the message was actually received. Perfect. Hello from Apigee. Great. So it's working. Wow. Well, folks, this has been a very long video. If you've been following along this whole time, good job. You're a true API geek. By now, you should be an expert on how to create Java callouts and how to troubleshoot them in Apigee. So I hope you found this video useful. If you did, leave a like. And if you have any questions or comments, leave them in the comments below or go to the Apigee community, and I'll see you in the next video.